So we're going to verify a trig identity. So we'll do what we're supposed to do here. We're going to say cosine x, cosine y, minus sine x, cosine y. That's not cosine, sorry, sine y. And then let's see, we'll do this next part. This is times, right? Times cosine x, cosine y, plus sine x, sine y. And we're supposed to get cosine squared x minus sine squared y. Alright, so let's see what happens. We're going to multiply. These are conjugates of each other, so I don't expect to get a middle term, and I won't. But I will get cosine squared x, and I will get cosine squared y. And then, let's see, when I go with the last terms, I get negative sine squared x and sine squared y. And I'm supposed to be equal to cosine squared x minus sine squared y. In other words, I would like to do something about this one, because that's not supposed to be there. And something about this one, because it's not supposed to be there either. Alright, so let's see what I can do. I will say cosine squared x, and instead of saying cosine squared y, I can say 1 minus sine squared y, right? Because of the Pythagorean identity. Minus, instead of saying sine squared x, I'm going to say 1 minus cosine squared x, because that's the same thing according to the Pythagorean identity again. Okay, so now let's see if I distribute this. Do I need to distribute it? Yeah, I think I do. We'll say cosine squared x minus sine squared. Maybe I should do the x first. I'll do the x first. I'll say cosine squared x, sine squared y, minus, so we're multiplying by a negative and also the sine, so I'm going to get sine squared y. And then it happens again, and I'm going to say negative times a negative is a positive times this. So I'm going to get x first would be cosine squared x, and then sine squared y. And I say, well, hey, these are the same thing but different signs, so they're gone. And I get cosine squared x minus sine squared y, which is indeed what's on the other side. So I have verified the identity because I got the same thing on both sides.